All right, here we are on example 9 in the Principle of Mathematical Induction packet. If you have not yet tried this problem on your own, please pause the video now and go try it. You should be able to get this one. Example 9, we are proving that this equation down below is true. The equation is the sum from r equals 1 to n of terms in the form 4r minus 6 should equal 2n times n minus 2. The first step is to do the first case. So the first case would be, instead of going from 1 to n, you go from 1 to 1, which is not really adding anything. You just look at the first term. So sub in r equals 1 into here. 4 times 1 minus 6. 4 times 1 minus 6 is 4 minus 6, which is negative 2. Also sub in a 1 for n on the right-hand side. 2 times 1 times 1 minus 2. 2 times 1 is 2. 1 minus 2 is a negative 1. Negative 1 times 2 is negative 2 on the right, which is also equal to the negative 2 on the left. Check. Step 2 is my assumption step. Assume that my statement is true when all of the n's equal k. Again, notice that the r does not change on the bottom. The k up there, the former n up there changes to a k. The former n's there and there both change to k's. The r is still the same. Again, it's true for all positive integers of k. Next, remember the first strategy that we looked at was where you just add one more term to both sides, and so that's what we're going to do. My sum stopped at k before, so the next term would be when I have a k plus 1 in place of that r there, right? So that's adding one more term on the left, and also add the same one more term on the right. Left side won't change for the rest of the problem. On the right, there's a lot here. Let's simplify it. The 2k here can distribute in to give me 2k squared minus 4k. This 4 can distribute into the light blue parentheses to give me 4k plus 4. The minus 6 is still on its own at the very end. This is a lot, but I can simplify and combine like terms. 4k minus 4k disappears. 4 minus 6 is a negative 2. The k squareds don't combine with anything. Right now, you should see this and you should say, oh, I can factor. 2k squared minus 2, I can factor 2 out of both of those, right? Then you should see what's left in the parentheses, and this should be very familiar. You should remember factoring quadratics. This looks like one of the formulas that we talked about before. It is a difference of squares, so k squared minus 1 should factor into k plus 1 times k minus 1. Notice my structure is almost perfect as I need it. The 2 is originally up front there. This k should be a k plus 1. It is. This k minus 2 should be a k plus 1 minus 2. And it is, because k plus 1 minus 2 is k minus 1. So now I have my entire structure with k plus 1s in all the places that originally had k's, so you can replace those with n's, right? And so if n equals k and n equals k plus 1, then by the principle of mathematical induction, the sum from r equals 1 to n of 4r minus 6 does equal 2n times n minus 2 for all positive integers of n.